Okay, so this is what, section 3.5, geometry, symmetry. If you want to follow along in the book, this is, let me get there. Section 3.5 begins on page 259. Okay, and we're going to talk about symmetry.
Why is Leon misspelled?
No, it's not misspelled. It wasn't supposed to be Leon. It's supposed to be Elon. Elon Musk.
Leon.
Yeah.
Oh yeah, why is it? I was gonna say, usually it's Leon.
Well, it started out as Noel, so. Okay. What can you tell me about symmetry?
Same on both sides.
Same on both sides. So give me an example of symmetry.
Triangle. Well, not all, I guess. Sorry.
No, you're
What did you just say to me?
A square.
a square, okay, has symmetry.
A circle.
A circle has a lot of symmetry, doesn't it?
Diamond.
Diamond, okay. What about your face?
No.
I mean, your eye could be further this way.
Yes, but for the most part, is your face symmetry?
Yeah.
Okay. Okay, if you took your face and you took a line right down the middle and you folded your face, you could do that. It would match up pretty good. People, if I took half of Dylan's face and put half of Kellen's face on it, it would look really weird because nothing's going to match up. And so, do you think that we find pleasure in symmetry?
Yes.
Most of the time we do, don't we? Let's take a figure and just look at a figure. It's hard to draw, but I'm going to draw a pentagon. Pentagon is a five-sided figure, okay? By the way, I watched a guy on the other day in a video that asked a lady on the street what a six-sided figure was, and she didn't know. He said a hexagon, and she goes, "Well, how am I supposed to know that? I'm a lawyer." I thought, yeah, you're right. You're right. You're a lawyer. You're not supposed to be very bright. Amazing that you got through school and not knew that. Okay, let's say that this looked like this, and I drew it so the sides were matching. Symmetry, then, we have two kinds of symmetry, and we're going to start with the first type. It's called line symmetry. Okay, line symmetry is when we can draw a line such that we can fold it on that line, and every side of this side matches every side of that side. Now, obviously, it's hard to draw, okay? But this has one line of symmetry. Is it possible to have more lines of symmetry?
Yes.
It is, okay? So line symmetry looks like that. Rotational symmetry is if we can rotate it 180 degrees or less, and it matches itself. Okay? So if you could turn it 180 degrees either way, it matches itself. Does it in this case?
No.
No, it does not. Okay? All right. Any questions about that? All right. So knowing these things, we're going to move to, and I'm going to move to what Aubrey was talking about. This is an equilateral triangle. This is an equilateral triangle. All right. Does it have lines of symmetry?
Yeah.
All right. And what are they?
Down the center.
Down
line.
the center? Okay. Is that the only one?
Mhm. Because you can't do a cross.
Can't you do it like this? It has three lines of symmetry, does it not? Okay. All right. So now when I talk about rotational, I rotated on a point. I didn't make that clear. I'm pretty sure I didn't say that. But it's rotated on a point, isn't it? Okay. This one did not have it, but does this one? Does this have rotational symmetry? In other words, can you turn it, and in less than 180 degrees or at 180 degrees, does it match itself?
Yes.
Yes, it does, doesn't it? And it turns on this point right here, doesn't it?
Mm-hmm.
Okay, now here's the kicker. We have what we call an order of symmetry. Now the order of symmetry, I think that's what this book calls it, is the number of times that it can match itself in 180 degrees. The book says that the number of times figure maps onto itself as it rotates from 0 to 360 is called okay? So the number of times that it matches itself, okay, is the order of symmetry, all right? So if I start turning this 360, how many times does it match itself? 3 times. So the order of symmetry is 3 times, okay? All right. The next thing we want to talk about is the magnitude of symmetry. Magnitude. Anybody know from science what magnitude means? It means size. It means size. You're correct. So the magnitude is the angle of rotation. So it's the angle of rotation. All right. So I'm going to tell you something. The magnitude is equal. Remember that Dylan said this was the size. So the magnitude is equal to 360 degrees, because that's the number of times that you could, that's the full rotation, divided by the order of the magnitude, or excuse me, the order of symmetry. Okay? So in this case, in this particular case, it's 360 divided by what?
3.
Which is 120 degrees. So the magnitude is 120 degrees. Yes?
On our assignment, it says, like, if so, draw all lines of symmetry and stick a number. Is that the number, or would 3 be the number?
3 would, this, the first one,
Yeah.
the lines of symmetry, you draw, which I did, and then you would say,
Right?
you would say 3.
Okay.
Okay? That kind of separated. Okay? Yes. So, on the number 1 would be very similar to the one we just did, right?
Mm-hmm.
Okay. What would be, well, let's take a look while we're doing this. Let's take a look. It's not gonna take you very long to do this, is it? Okay. What about this one?
The second one?
Yeah, number 2.
No.
Okay, there's no lines of symmetry. I think some people think you could do it like this, but then if you folded it, it wouldn't match, would it? Okay. So you're gonna do these 4. You're gonna do it exactly like this one. You're gonna draw the lines, right? Now, the first 4 are just lines of symmetry. So I'm gonna draw the lines of symmetry, and then I'm gonna state them, how many there are, okay? Now, if it doesn't have any lines of symmetry, we say no, okay? Then the last ones, what I want you to do is state whether it has rotational symmetry, so yes or no, okay? And then locate the center of symmetry. Remember that I located the 1 there? Okay, now if it doesn't have symmetry, rotational symmetry, will it have a point of symmetry?
No.
No. If it doesn't have rotational symmetry, it will not have a point. And then state the order and magnitude of the rotation, okay? So the order is the number of times that it matches itself in 360 degrees, and then the magnitude is 360 divided by that. And so it's a degree. You understand that, Tyra? Tyra?
Yeah.
The magnitude is a degree. Okay, now you had a concerned look on your face earlier. What was that about?
No, I understand.
Okay, all right.
Should we do one of the bottom ones together?
Which one would you like to do?
8.
8? I'd love to do 8. Why? It doesn't have any. So my answer is no,
well,
and
then
that's it.
it's
Nope,
two.
I'm done. I'm
No,
done.
no,
No. You can do the rest of it. Yes, this is how it works. So yes, 8 is no. Way to jump in.
It has a point and a curve.
Yeah, it has a point in it, so it doesn't have rotation.
There is no points, Melcha. If it's no, there's no point. There's no point.
It doesn't have a point of symmetry if it's no. Okay? So, all right.
She said also 8 guys today.